it visible to you? Anyone can reply. Is PDF visible to you? Not visible? 1 minute. Connection was the- Now, is it visible to you? Okay. So, we are learning about the degradation pathways, various degradation pathways. In that, most important pathways that we have considered: hydrolysis, oxidation, and in the oxidation, yeah, until this we have covered. Now, next point that we are going to cover is the oxidation reaction are governed by the following principles. Basic oxidation reaction need to be understood. The oxidation rate increases with presence of atmospheric oxygen or air. This also we have covered. Organic molecule also we have covered. Dihydroascorbic acid means this. From this example, you can come to know that when vitamin C will come in contact with atmospheric oxygen, vitamin C will be our original drug. Due to when it will come in contact with uh, atmospheric oxygen, it would get converted into dihydroascorbic acid. Means original molecule will be lost, and degraded molecule will be, yes, not visible. Wait a minute. Okay. Connection focus problem. So I think it will be visible now. So we are taking the example of ascorbic acid, vitamin C, structure of both the degraded and original form of the product has been given. It would get oxidized and getting 2-hydroascorbic acid. In the presence of copper ions, in 0.02 molar concentration, the oxidation rate of ascorbic acid increased by the factor of 10 raised to power 5. Oxidative degradation reaction can be prevented by using following approaches. Antioxidant. Many natural examples are tocopherol, ascorbic acid, and synthetic antioxidant. For example, butylated hydroxytoluene, butylated hydroxyanisole are widely used in foods, cosmetics, and drugs to inhibit oxidative reactions. So these are the examples. When we add it into our formulation, it will responsible for the reduction of oxidation process. Mechanism of this agent is to break the free radical chain reaction at the chain propagation step. When the chemical reaction is occurring, the free radical will get generated, and that generated free radical will take part or initiate the new degradation reaction. And the end product of that degradation reaction will be again a new free radical. So this free radical generation are only the main problem, and these antioxidants is retarding. So by adding the antioxidant, the oxidation process can get stopped or retarded. Similarly, chelating agent. These agents are used in heavy metal catalyzed oxidation reaction. Chelating agent examples are ethylene diamine tetraacetic acid, tetraacid, citric acid, and acid. Chelating forms complexes with heavy metal ions. Thus, free metal ions becomes unavailable to catalyze the oxidation reaction. If free metal would be unavailable for the oxygen to get combined, obviously further oxidation will not occur, and that will get done by chelating agent. Instead of combining with oxygen, these metal ions get combined with chelating agent, and thus preventing from oxidation. Similarly, buffers. The oxidation reaction catalyzed ions, basically specific acid-base catalysis reaction would be there, can be controlled by buffer ability determined for each drug. Buffer provide maximum stability to the product. So in this way, addition of oxidizing agent is responsible for the prevention of oxidation. At the same time, buffer is also useful to resist the change in pH if the drug would get degraded by any other pathway of degradation apart from oxidation. The next one is the vehicle. For most of the pharmaceutical preparations, water is used as a solvent to dispense the drug. Sometimes water is replaced by some other solvent to stabilize the drug, while water used along with other solvent catalyze the oxidation reaction. So by alteration of vehicle, we can retard the oxidation reaction. This is one of the another approach that we can do. नहीं, connection चा problem. Hello, am I audible now? Okay. So one more time, I'm sharing the PPT. So by avoiding the contact of heavy metal such as iron, cobalt, nickel, this would be a better choice in prevention of oxidation. So that manufacturing firms are mostly using the stainless steel of higher grades so that they can avoid these metals to become in contact with our formulation. Photolytic degradation would be the next one. Photolytic degradation and its prevention. Photolytic means it would be accompanied with light. Photo light. Photolighting means with the help of light. When degradation of light sensitive drug molecules is getting degraded by the light presence of light, and that process is called as photolysis. It is a degradation of photodegradable molecules caused by the absorption of photons or photons, particularly those these wavelengths found in sunlight, such as infrared radiation, visible light, and ultraviolet light. Okay, so as we know, our sunlight is composed of so many things, so many wavelengths: infrared light, UV light, and our visible spectrum is also there. Everything is, you can say, there in our sunlight. But uh, but we can see, we can get help of visible range only, visible wavelength range only. But other things are also there when sunlight getting exposed to us. So that too much sunlight is also harmful. Small sunlight is also harmful or not creating the benefits in case of vitamin D. So that just like this, so many drugs are also there which can get degraded by all these wavelengths of light, especially infrared and ultraviolet light. So that we should avoid the exposure of our drug molecule towards the sunlight. Some molecules get activated by the heat of light, which increases the reaction rate. Hello? Hello? Am I audible to you? Hello? Hello? Am I audible to you? I am not getting your voice. Say louder. Hello? Okay, okay. So, discussing about the light, so what is happening? Some molecules get activated by the heat of light, which increases the reaction rate. So, mechanism is very simple. Several times we have discussed, we have understood that light is one of the form of energy. Light is, in another way, light is electromagnetic radiation in which energy got trapped and carry forwarded. So basically when the molecules get supplied with the light, get exposed to light, the molecules gain with energy from that light. And when they will gain with energy, they got acquainted with the absorb with higher energy. Uh, they get converted into higher energy state, and due to higher energy state they occurred, they start more randomness. More randomness promote more collision. More collision promote more probability of occurrence of reaction. So that we have understood yesterday. So these things basically originated from the exposure of light, and due to exposure of light, the collision will get started up to much more extent, and due to that the rate of reaction will get increased. Okay, so this is the basic mechanism when light will get exposed to the susceptible molecule, and that is called the photodegradation. Involves combining action of sunlight and air. It involves the process of oxidation, loss of electron, and increase in oxidation state, and hydrolysis, split of chemical bonds by adding water. So this photodegradation will encourage, will catalyze the other degradation pathway also, so that the other degradation pathway will get associated with photolysis is oxidation and hydrolysis, that we have already seen how they are occurring. Drugs which get chemically degraded in the presence of light are photosensitive or photoliable drugs. Example of photochemical reaction: color fading or color development. Ergosterol convert into vitamin D when exposed to ultraviolet light. This is the endogenous production of vitamin D by our skin cells. Chlorophyll absorbs visible light and undergoes photosynthesis, forming carbohydrate and oxygen. So this is also a photocatalytic. Examples of drug that undergo photolytic degradation are ascorbic acid, chlorpheniramine, riboflavin. All these are vitamins. Hydrocortisone, tetracycline, antibiotic, prednisolone, hormone or steroid. So basically there are several other examples also, but these are the most prominent one. Photolytic degradation can be prevented by how? Packaging of drug in amber colored bottles, packaging of drug in cardboard outers, so that you will see that our formulation is associated with so many boxes, not directly bottles are supplying. So a bottle getting stored in a carton, and several cartons getting stored in a shipper. Shipper means that वो बड़ा वाला कार्डबोर्ड रहता है ना अपना पैकिंग वाला. So that is a shipper, and that shipper will get carry forwarded then for the transportation. So basically it is for the prevention from exposure to light. Packaging of drugs with aluminum foil overwraps. When we supplied with food, or when we supplied with some medicine capsules, at that time you will see that from one side it is a PVC when blister packing will be there, and on the other side it will be aluminum packing. So from the aluminum packing we can take out the medicine. At the same time it is responsible for the prevention of degradation, and drug can be stabilized against photolytic degradation are as follows. Temperature. Drugs should be stored at appropriate temperature so that thermal acceleration of decomposition is avoided, that we already discussed. Light sensitive drugs should be stored in amber color bottle to protect the product from deterioration, means degraded effect of light. Humidity. The drug should be packed in glass and plastic material to prevent the exposure of drug to high humid conditions, so that we can prevent the drug from hydrolysis. Moisture will not be there. Oxygen. While packing the oxygen sensitive drugs, the oxygen content of the solution should be kept less, and very little head space should be left in the bottle above the product. Head space means what? Am I audible to you? Head space means what? The gap in between the solution and the closure. That would be a head space. So when the headspace would be minimum, more and more formulation would be there, so that the headspace would be minimum. Obviously, there would be less chances of presence of oxygen. Means less quantity of oxygen will be there because headspace would be minimum, and that can keep. Use of coating agent. Earlier I told that coating, mostly we are using the film coating. In various dosage forms, coating agents are used for the photostabilization of drugs. Yellow, red and black iron oxide are used as opacifiers for the protection of uh, sorvidine. Means these are the examples of different tablet they have given, and means what we are doing, we are coloring the tablet. Usually we are using the color to increase the aesthetic appeal for the patient. At the same time, if you can use the color, because colors are opacifier, color is you can say removing the transparency, transparency, so that the light will not get reach into up to the uh, inside of the tablet or surface of the tablet, because color barrier would be there, so that we can protect the drug, our drug, from the degradation by adding the color also. But color is carcinogenic also, so that what we need to add the FDA approved color. Okay, uh, so that we can and we can use the concentration with permitted by FDA only, then only it would be possible for to do all these things. Complexation. Complexing agents are used for the stabilization of photosensitive drugs. Earlier we have discussed how complexing agents are doing their task. Caffeine is used as complexing agent for the photostabilization of riboflavin. Riboflavin, it is a water soluble vitamins, a highly photosensitive drugs. Use of stabilizers. The photostabilization of drug is done by the use of stabilizers. For example, photostabilization of D-doxorubicin HCl by sodium thiosulfate. So these are few examples that we can mention over here. So all these are the, about the degradation, their mechanism, their details, and all these things. Okay, chemical reactions are not to be accompanied by you. You can give the elaboration, you can give the correlation, you can give the justification for all these degradation mechanism. One chemical reaction would be self-sufficient to elaborate the particular degradation mechanism. Okay, but what is expected, that you should discuss all the facets, all the aspects of these each and every degradation pathways. Is it clear? Is it clear to all of you? Huh. So next point is the drug stability. Now this also we have covered in our practical, and during the practical only we have already tried up to too much extent. Will come into play. This would be a last discussion part for this chapter. Am I audible to you? Then my connection may get loose, so that I am asking you several times. So to be continued. Accelerated. Now I am not going into the details of accelerated stability testing, because we have already learned, done, understood very well during our last practical. Okay, so whatever which has been left, that I am going to cover in detail. I guess you are having you got a good understanding of accelerated stability testing, why it is needed to be done, and all these things. But still, I am covering all the points superficially, and whichever the point which has been left earlier, that I am going to cover in detail. Okay, so accelerated stability testing in expiration dating of pharmaceutical dosage form. Accelerated stability testing Am I audible? Hello? Okay. Now, जसं की आपण आयसोलेटेड स्टॅबिलिटी स्टडी करत होतो आणि तिथे आलं वर्ड लेबल पोटेन्सी. लेबल पोटेन्सी बद्दल तुम्हाला समजून सांगत आहे. लेबल पोटेन्सी इट इज बिंग असोसिएटेड विथ प्युरिटी. प्युरिटी म्हणजे काय बघा. पुन्हा स्टार्ट करतो. मी ऑलरेडी एक्सप्लेन करणं चालू केलं होतं, परंतु व्हॉइस हॅज बीन लॉस्ट. So still I am what you call giving one more time explanation. See, 100 mg drug we have taken. 100 mg we have weighed the 100 mg and then we have taken 100 mg powder of a particular drug. So what we are assuming, we have taken 100 mg drug. 100 mg drug घेतलं म्हणजे आपल्याला काय वाटतं की त्याच्यात 100 mg आपला ड्रग आहे, म्हणजेच तो 100% प्युअर आहे. तो पावडर जो घेतलाय आपण तो 100% प्युअर पावडर आहे, म्हणजे 100 mg त्यात ड्रग आहे. परंतु असं नसतं. इट इज नॉट. देन व्हॉट इज देअर इन 100 mg पावडर? बिकॉज वी हॅव वेट द पावडर. वी हॅव वेट द पावडर which is absolutely accurately weighed 100 mg. But what is there always? 100 mg drug will not be there. It is a powder only that you have weighed. But कोणता पण पावडर हा थोडा ना थोडा त्याच्यामध्ये इम्प्युरिटी असतो. कोणत्याही पावडरमध्ये, ड्रगच्या पावडरमध्ये थोडी ना थोडी दुसरी इम्प्युरिटी असते. दुसरी इम्प्युरिटी. ओके, ट्राय टू अंडरस्टँड. व्हेरी व्हेरी इम्पॉर्टंट कॉन्सेप्ट. इट वुड बी हेल्पफुल फॉर युअर अनालिसिस ऑल्सो फॉर एव्हर. पोटॅन्सी प्युरिटी बद्दल सांगत आहे मी. सो कोणताही ड्रग जो असतो तर तो आपण 100 mg वे केला, परंतु त्यात तो 100 mg कधीच नसतो. व्हेरी व्हेरी लेस चान्सेस. कदाचित त्याच्यात ड्रग असतो 98 mg. 98 mg. मग 2 mg काय आहे, 2 mg काय आहे? 2 mg त्या पावडरमध्ये त्याच कलरची, कदाचित समजा व्हाईट पावडर आहे, त्याच कलरची इम्प्युरिटी असेल. आर यू गेटिंग द पॉइंट? ट्राय टू अंडरस्टँड द कन्सेप्ट. सो in our 100 milligram powder that we have weighed, how much drug is contained in terms of weight? 98 mg. And how much impurity is there? 2 mg. Means what we can say? In another words, in terms of percentage, we can say that in that 100 mg powder, 98% of drug is there only. 98%. कारण की 98 mg आहे. 98% of drug is there. Okay. And 2% of impurity is there. म्हणजे आता आपण दुसऱ्या शब्दात त्याला काय म्हणावं, तर आता आपण त्या कंटेनरमधून, तो कंटेनर तर ड्रगचाच होता संपूर्ण. आपण असं म्हणू शकत नाही की तो ड्रग इम्प्युअर आहे. आपण तसं म्हणायचं नाही. आपण काय म्हणायचं मग, म्हणजे कशी लँग्वेज असते सांगण्याची, मांडण्याची, लिहिण्याची. तर ड्रग इज 98% प्युअर. अंडरस्टूड ऑर नॉट? टेल मी. ड्रग इज 98% प्युअर. ओके. हॅलो. हा म्हणजे आता सांगताना तुम्ही काय सांगाल की आपण हे सांगू शकत नाही, आपण हे सांगायचं नाही की तो जो कंटेनरमधून आपण ड्रग घेतलाय तो चांगला नाही आहे, त्याच्यात इम्प्युरिटी आहे. नाही, तसं नसतं. तुम्ही कोणताही ड्रग घ्या, नॅशनल घ्या की इंटरनॅशनल घ्या, तुमच्यात इम्प्युरिटी असतेच. तुमच्या ड्रग प्रोडक्टमध्ये इम्प्युरिटी असतेच. मग तुम्हाला त्या ते रिपोर्ट करावे लागते की हा जो ड्रग आहे याची पोटेन्सी आहे 98%, याची प्युरिटी आहे 98%. ओके. मग आता तुम्हाला जर का तो ड्रग जर का 100% असा हवा असेल, ट्राय टू अंडरस्टँड. जर का तुम्हाला ड्रग आता जर का तुम्ही 100 mg घेता तर तुम्हाला 98% ड्रग मिळतो. ओके. 2% प्युरिटी मिळते. मग जर का तुम्हाला 98% न मिळवता, न घेता तुम्हाला हवा असेल 100% ड्रग, मग तुम्हाला काय करावं लागेल, थोडा आणखीन ड्रग 2% आणखीन पावडर त्यात ओव्हरेज म्हणून ऍड करावं लागेल. ओव्हरेज म्हणून ऍड करावं लागेल, तेव्हा कुठे तो 100% ड्रग होईल त्या पर्टिक्युलर क्वांटिटीमध्ये. मग तो ड्रग, तो पावडर जो आहे तो क्वांटिटीमध्ये जास्त दिसेल, परंतु प्युरिटीमध्ये तो 100% झाला असेल. म्हणजे 100% म्हणजे आपण जो म्हणतो की त्याच्यात जेव्हा आपण लेबलवर लिहितो की त्याच्यात 100 मिलीग्राम ड्रग आहे, म्हणजे याचा अर्थ पावडर, त्या ड्रगचा पावडर आपण किती टाकलेला असेल, तर 102 मिलीग्राम पावडर टाकला असेल, तेव्हा कुठे आपल्याला त्याच्यात 100 mg ड्रग मिळेल. मग समजा एका कंझ्युमरने एखाद्या किंवा FDA मध्ये चेक केलं की इथे तर लिहिलेलं आहे, लेबलवर लिहिलेलं आहे की 100 mg ड्रग विल बी देअर, इज देअर, लेबल क्लेम, लेबल पोटेन्सी त्याला म्हणतात, परंतु ड्रग तर 98 mg आहे, म्हणजे यू वुड बी यू वुड क्लेमिंग अ फॉल्स स्टेटमेंट. तर तुम्हाला अटक होऊ शकते, म्हणजे मॅन्युफॅक्चररला. कारण की प्रत्येक बॉटल मागे तुम्ही, प्रत्येक टॅबलेट मागे तुम्ही 2-2 mg ची कॉस्ट तर घेताय, पैसे तर घेताय, परंतु तेवढा ड्रग देतच नाही आहात. आर यू गेटिंग माय पॉइंट? तर दॅट इज कॉल्ड द प्युरिटी, potency, label claim, and all these things. Okay, so this is all about the things that we need to understand. Now let me share the screen. So that to be continue with our discussion, chemical types of stability, chemical stability. So I have explained the point about labeled potency, physical appearance and uniformity. Whichever we have manufactured, it should look alike, smell alike, test alike, similarly up to its shelf life. That is expected from the physical stability. Microbial stability, it should be free from microbes, ideally. Therapeutic stability, whatever the whichever the drug that we have taken, it must show its therapeutic activity. If paracetamol will be taken, then it should retard the fever. If phenytoin is taken, anti-epileptic drug, it should retard or prevent the epilepsy. Similarly, toxicological specification, no increase in toxicity. So that is called the toxicological stability. Now, accelerated stability studies. Accelerated stability studies analysis is designed to predict stability and shelf life of formulations under normal or recommended storage condition by carrying out the study under accelerated conditions of temperature, moisture and light that we already discussed in RNS equation in our practical. म्हणजे by conducting the degradation study at elevated temperature, at स्ट्रेस कंडिशन, याला म्हणतात स्ट्रेस कंडिशन. जेव्हा आपण नॉर्मल कंडिशन पेक्षा जास्त कंडिशनला ड्रग फॉर्म्युलेशन एक्सपोज करतो त्याला म्हणतात स्ट्रेस कंडिशन. ओके, एका आस्पेक्टने. मग त्यात लाईट पण आला, टेम्परेचर पण आलं, मॉइश्चर पण आलं, म्हणजे एक्सेस अटमोस्ट. सो ॲट दॅट टाइम when we are getting the data, from that data only we can predict the shelf life of the drug formulation. म्हणजे समजा 60 किंवा 80 डिग्री सेल्सिअसवर जर तो एवढ्या टाईमपर्यंत ऑटिकॉल डिग्रेडेड होत नाही आहे टोटली, मग त्याच्यावरून एक्स्ट्रापोलेट करून तुम्हाला 25 डिग्री सेल्सिअसवर तो किती दिवसापर्यंत त्याचं डिग्रेडेशन होण्यापासून वाचेल ते तुम्हाला प्रेडिक्ट करता येतं. इट इज हॅव्हिंग द कॅल्क्युलेशन. ओके, कॉमन हाय स्ट्रेस कंडिशन आर एज फॉलोज. टेम्परेचर वाढू शकता, ह्युमिडिटी वाढू शकता, लाईटचा एक्सपोजर जास्त करू शकता. दीज आर द वेज बाय विच वी कॅन इन्क्रीज द स्ट्रेस कंडिशन. ऑब्जेक्टिव्ह काय आहे ॲसिडिटी स्टॅबिलिटीचा? द to serve as a rapid means of selecting the best formulation from amongst a series of similar formulation of the product. जेव्हा आपण वेगवेगळ्या बॅचेस बनवतो फॉर्म्युलेशनच्या, तुम्ही नंतर फायनल इयरला हे करणारच आहात, तुम्हाला एक फॉर्म्युलेशनसाठी कदाचित 9 बॅचेस, 18 बॅचेस, 27 बॅचेस, 56 बॅचेस एवढा बॅचेस करावं लागणार आणि प्रत्येक बॅचेसचं तुमचं कंपोजिशन वेगवेगळं असणार. एम आय ऑडिबल टू यू? हॅलो? येस. सो म्हणजे प्रत्येक फॉर्म्युलेशनमध्ये तुम्हाला वेगवेगळं कंपोजिशन घ्यावं लागणार प्रत्येक इन्ग्रेडियंटचं. म्हणजे तुमच्या वेगवेगळ्या बॅचेस होतील वेगवेगळ्या कंपोजिशनच्या, आणि त्या प्रत्येक बॅचेसला तुम्हाला अशा कंडिशनवर ठेवावं लागेल, ॲसेलरेटेड कंडिशनवर ठेवावं लागेल फॉर द 3 months, फॉर द 6 months. म्हणजे तुम्ही स्टॅबिलिटी स्टडीज कंडक्ट करत आहात असा त्याचा अर्थ होतो. ओके, आणि तुम्हाला करावं लागणार नंतर, तर त्याकरता नॉलेज आताच घेणं जरुरी आहे. टू प्रेडिक्ट द शेल्फ लाईफ ऑफ द प्रोडक्ट, टू सर्व ॲज अ रॅपिड मीन्स ऑफ क्वालिटी कंट्रोल, एक्सपायरेशन डेट और शेल्फ लाईफ. हे आपण झालेलं आहे. पुन्हा एकदा सुपरफिशियल वाचतो. द एक्सपायरेशन डेट और शेल्फ लाईफ ऑफ अ ड्रग इज द टाइम interval for which a drug product is expected to remain within an approved shelf life specification, provided that it is stored according to the label storage condition and is packed in the original container closure system. आपण स्ट्रीपमधून गोळ्या आणल्या, समजा फॉर एक्झाम्पल स्ट्रीप आणल्या आणि स्ट्रीप कॅरी करायला आपल्याला परवडत नाही, मग आपण घरचं काहीतरी कंटेनर घेतलं आणि त्यात गोळ्या सेव्ह केल्या, स्टोअर केल्या, तसं चालत नाही. ज्या प्रकारे तुम्हाला ज्या फॉर्ममध्ये तुम्हाला सप्लाय केलेलं आहे त्याच फॉर्ममध्ये तुम्हाला ते मेडिसिन ठेवावं लागतं, आणि तरच ते ठराविक मर्यादेपर्यंत त्याचं डिग्रेडेशन होत नाही, किंवा फक्त 10% डिग्रेडेशन होतं. T90 म्हणजे एक्सपायरी डेट, T90 म्हणजे एक्सपायरी डेट ही त्या कंटेनरला, स्टोरेज कंडिशनला फॉलो करूनच कॅल्क्युलेट केली जाते. On the container or label of the drug product designing the time after which it should not be used. The drug's potency begins to diminish. Earlier I told, एकतर तुमची पोटेन्सी बघा, तुम्ही पुन्हा तुम्हाला आता पोटेन्सीला आपण 100 मिलीग्राम ड्रग घेतला म्हणजेच तुम्ही पूर्ण पोटेंट ड्रग घेतला असं नाहीये. त्याच्यात 100 मिलीग्राम ड्रग कधीच नसतं, त्याच्यात त्याच्यापेक्षा कमीच असतं, पण जास्तही कमी नसतं, त्याच्यात काहीतरी प्रमाणात कमी असतं. 90 म्हणजे त्याच्यात पण परमिसिबल दिलेलं आहे, नॉट लेस दॅन 97%, नॉट मोर दॅन 102%. मग त्याच्यामुळे काय होईल, डोजचं कॅल्क्युलेशन चुकेल, बरोबर ना. ह्याच्यामुळं तुम्हाला जेव्हा तुम्ही डिग्रेडेशन, ड्रग डिग्रेडेशन होतं त्यावेळेस जो पोटेन्शियल सप्लाय केला त्याच्यापेक्षाही कमी होते. व्हेरी व्हेरी इम्पॉर्टंट थिंग्स टू बी कन्सिडर ॲज अ फॉर्म्युलेटर. हे जे शिकवलं पोटेन्शियल बद्दलचं, प्युरिटी बद्दलचं, ते तुम्ही कधीही विसरता कामा नाही. हे लक्षात ठेवा, तुम्हाला नेहमी ते कामात पडणार आहे. कन्सेप्ट जर का रॉंग, थोडा मिसअंडरस्टूड झाले असतील तर आपापसात डिस्कस करा. तुम्ही मला तर विचारतच नाही, हे तर तुम्ही म्हणजे ठरवूनच टाकलेलं आहे, तर कमीत कमी आपापसात डिस्कस करा, जेणेकरून तुमचे याबद्दलचे कन्सेप्ट क्लिअर होतील. आणि समजा असं वाटलं की नाही सरांना काहीतरी येतं, सरांना पण विचारावं, तर विचारून घेत जा एखाद्या वेळेस. हा, ठीक आहे. देन amoxicillin example. Amoxicillin suspension has an expiry date of 14 days when started at room temperature, stored at room temperature 25 degrees Celsius, while trimethoprim sulfamethoxazole combination tablet have a shelf life of 5 years when stored below 30 degrees Celsius. Very very vast, you can see. Trimethoprim sulfamethoxazole combination, brand name is Tiprim by Alkem. Actually I was formulating uh, the TIPRIM, that is trimethazole sulfamethoxazole, when I was working with Alkem Laboratories a few years back. It is having very good expiry. It is 5 years. So expiration date release related to specific storage condition stated on the label should be derived on the data obtained from an appropriate stability testing program. Program means FND. So all these about the drug stability. So with this we will stop for today, and then further we will cover the next thing. Mostly we have covered all the things, and few things are remaining. Some calculations are remaining, and ICS guidelines are remaining. That's it. So with this, I am going to take the lecture at 4 p.m. So by today itself, we will going to finish this chapter, and then we will start from tomorrow onwards. We can start with macromeritics. Okay. So this is all about, yeah. How many students are there? Near about 90. So tell the others that they should be there in the lecture. Okay then. Thank you very much.